Hi everyone, welcome back to my video about programming in Java. This video is part 2 of arrays in Java. In the video for part 1 of arrays in Java, I have covered the first 3 sections about arrays, including primitive types versus reference types, array basics, and declaring and creating arrays. This video will cover the next 4 sections about arrays in Java. Section 4 covers several examples using array. Section 5 covers enhanced for statement that goes through an array. Section 6 shows you how to pass arrays to methods. And Section 7 will discuss the difference between pass by value and pass by reference. Let's start with the first example using arrays. This example is a Java program named initArray.java that creates a 10-element array and assigns to each element one of the even integers from 2 to 20. Those are the numbers 2, 4, 6, up to 20, etc. The first 2 lines of code inside the main method body are to declare and create an array of int elements, where the array size is given by the named constant array length, which is also called a final variable. The name constant must be declared before it is used in the array creation. If you attempt to modify a named constant after it's initialized in its declaration, the compiler will issue an error message. After declaring and creating array, the program has a for loop that goes through the indexes of the array from 0 to 1 less than the array length. Here it uses the length instant variable of the array to get the array length. In the for loop body, it assigns a value of 2 plus 2 times counter to the array element at index counter. So the element at index 0 receives value 2. The one at index 2 receives value 4, and so on. After this for loop, the program displays the values of the array elements in a 2-column format. The first column is the index and the second column is the value of the array element at the corresponding index. So it first displays the column headings. Then it has another for loop to display each array element in each row. And here is the output of the initArray.java program. You see that in the value column, it shows the values from 2 to 20 of the even integers. And here in this program, we use the array length constant to declare the array. In general, using a named constant or final variable to declare array size makes the program easy to read and to maintain. Like for example, anytime you want to get the array length, you can just use this constants. Or if you want to modify it, you can just modify it here in once. Often, the elements of an array represent a series of values to be used in a calculation. For example, The values in the array elements can be added together as shown in the program of example 2. This program sums the values contained in a 10-element integer array. This array is created and initialized using the array initializer. To add the element values together, we use a for loop that goes through the array, adding each element value to the variable total in each iteration of the loop, where variable total is initialized to 0 before the loop. The program ends with displaying the value of variable total, and here is its output. In example 3, I'm going to show a more practical application of using arrays. Many programs present data to user in a graphical manner, such as in a bar chart. In such a chart, longer bars represent proportionally larger numeric values. For example, we can represent a grade distribution in a bar chart where each bar represents the number of students getting the grade in the corresponding range. The longest bar here shows 4 students having grade in the range from 80 to 90. The bars representing value 2 are half as long as the bar showing the value 4. But for now, we have not learned enough Java features to write a Java program that displays a bar chart like this. But there's a simple way to display a text-based bar chart, that is to show its numeric value as a bar of asterisks or stars. This program named barcharts.java demonstrates how to display the bar chart of grade distribution in the previous slide with asterisks. The data for the chart is stored in an array of 11 integers. The element at index I in the array holds the frequency of grades in the range from 10 times I to 10 times I plus 9. So array 0 holds the frequency of grades in the range from 0 to 9. And array 8 holds the frequency of grades in the range from 80 to 89, and so on. After grading the array, the program displays the bar chart title, which is grade distribution. Then it has a for loop that goes through the array elements. For each element, first it displays the grade range based on the index of that element. Note that for the last element, which has index 10, the grade range is just 100. For all other elements, the the grade range is of the form from 10 times I to 10 times I plus 9, where I is the index, and here the variable counter uh, holds the index of the current element. After displaying the grade range corresponding to the current array element, it has an inner for loop to display the bar of asterisks where the number of asterisks equals the value of the current array element, which is the indexed variable array counter. After this inner for loop, it has a println statement to move the cursors to the next line. This closing brackets is the closing brackets of the outer for loop, and this curly brackets is the closing brackets of the main method. And here's the end of the class bar chart. And this is the output of the bar charts.java program. And now you can see it display the range of the ranges from 0 to 100. And for each range, it display the uh, a number of asterisks corresponding to the value stored in the array elements. Our last example uses arrays to summarize data collected in a survey where 20 students were asked to rate on a scale of 1 to 5 the quality of the food in the student cafeteria, with 1 being awful and 5 being excellent. The program for analyzing the result of this survey is studentpoll.java. In this program, we place the responses from 20 students in an int array named responses, and we use a 6-element array named frequency to count the number of occurrences of each response. So a valid value stored in an element of array responses should be an integer from 1 to 5. But here we intentionally store an incorrect response in the last element of the responses array. This is to demonstrate how to handle an out-of-range error in array processing. This is the second part of the student-power.java program. The for statement in lines from 15 to 27 reads the responses from the responses array one at a time and increments one of the counters of frequency 1 to frequency 5. We ignore frequency 0 because the survey responses are limited to the range from 1 to 5. The key statement in the loop appears in line 19. This statement increments the appropriate frequency counter as determined by the value of the index variable response answer. This program also shows an example of error handling using the try statement. A try statement consists of a try block and one or more associating catch blocks. The try block contains code that might throw an exception, that is a runtime error. And each catch block consists of code that handles one type of exceptions that were through in the corresponding try block. In this example, the try block has only one statement, which increments the index variable of the array frequency. This potentially throws an array index out of bounds exception, which happens when the index provided by responses answer is not within the valid index range of the array frequency. So there's a catch block that handles this exception by displaying the error message of this exception. So here the the variable e is an object of this exception, and we print e it invokes the toString method that convert that exception to a string that can be printed out. And in this catch block, it also displays the value of the variable answer and responses answer that causes this exception. After the for loop, the program simply displays the frequency of each rating in a two-column table format, where the first column displays the rating from 1 to 5, and the second column displays the frequency, uh, which are stored in the frequency 1 to frequency 5. Here is the output of the student Paul.java program. The first line in the output is the error message of the array index out about exception, which also includes the value of the index that is out about. That index is 14, which is out about of the frequency array. The second line was the output of the print statement in the catch block of the array index out about exception. It shows that this exception was thrown when the answer is 19, which which is the index of the last element of the responses array, in which we intentionally place the incorrect value of 14. When a Java program executes, array elements indexes are checked for validity. All indexes must be larger than or equal to 0 and less than the array length. Any attempt to access an element outside of that range of indexes will result in a runtime error that is known as an array index out of bounds exception. But thanks to this catch block, the program still continues to run and displays the rating and frequency despite having a runtime error. Now let's move on to the next section, which is about the enhanced for statement. In all the examples we have seen, we always use a for loop that goes through the array elements. That is a typical way to process arrays. In those for loops, we used a counter variable to go through the indexes of the array and need to make sure that it doesn't step outside of the array. The enhanced for statement allows you to iterate through an array without using a counter, and thus avoiding the possibility of stepping outside the array. The syntax of the enhanced for statement also includes a for header followed by the loop body, just like the regular for statement. But the header of the enhanced for statement is much simpler. Inside the parentheses following the keyword for, there is a type, then a variable, then a colon, and then an array name, where type is the type of the array elements, and the variable will hold the values of the array elements that it goes through. While the enhanced for loop makes it more convenient to iterate through an array, there is one caveat. That is, the enhanced for statement can only be used to obtain array elements. It cannot be used to modify the elements or access the indexes of the array. In general, the enhanced for loop can be used in place of counter-controlled for statement whenever code looping through an array does not require accessing the array indexes except for reading the array elements. As an example, we will convert the for loop used in the sum array program into an enhanced for loop. Recall that this for loop iterates through the array elements to sum the integers in the array. In particular, it only obtains its array elements value and adds it to the variable total. The array elements are not modified, and the variable counter, which accesses the array indexes, is not needed except for to obtain the value of the array element. So we can replace this for loop with an equivalent enhanced for statement. Here we specify the element type int, then use a variable number to hold the array elements value, and specify the array name after the colon. And in the for loop body, we replace the index variable with the variable number. This enhanced for statement is equivalent to the for loop in the original sum array program. To give you more examples and a chance to practice with the enhanced for loop, let's consider the for loops in the other examples of using arrays that you have seen in this video, and determine which for loop can be rewritten as an enhanced for statement. We assume the array variable in these for loops is already declared and graded like this. I'll give you 10 seconds to think about your answers. Then you can come back to check the correct answer. Counting down. Okay, 10 seconds have passed, and here are the correct answers. The first two for loops cannot be rewritten as enhanced for statements because they need to access the indexes of the array elements beside reading the value of the array elements. In the first for loop, it needs the index, which is stored in variable counter, in order to calculate the value for array counter. So it needs the indexes in the calculation. In the second for loop, the index is displayed. So we need it. Therefore, in both cases, you cannot turn the for loop into an enhanced for statement. The last for loop only accesses the counter variable to read the value of the element at index counter. So it can be rewritten as an enhanced for statement. So the enhanced for statement that you can write here should have the type int, and you can use some variable name to catch the value of array counter, and after the colon you write the variable array, and then in this printf you just replace the array counter with whatever variable that you use in the enhanced for statement. How about these nested for loops? Which one can be rewritten as the enhanced for statement? Okay, so for this one, I give you a chance to think about it. I don't give you an answer, but the I like you to think about it to figure it out. You can find the answer by trying different way to rewrite as an enhanced for statement. If you don't get the equivalent result, that means it's not the that means that you may not be able to turn it into enhanced for statement. One of these can be turned into an enhanced for statement, but not both. So you need to figure out which one. Now we move on to section 6, which is about passing arrays to methods. For a method to receive an array reference through a method call, the method header must specify an array parameter in the method parameter list. An array parameter is specified by having the square brackets after the array element type, such as double, open square brackets, then close square brackets. In this example, A is an array parameter which can hold the reference to any array of double. To pass an array argument in a method call, we specify the name of the array without any brackets. For example, suppose array numList of double elements have been declared and graded, and not function, the method modify array has been declared to accept an array of parameter of double elements. Then we can call method modify array passing numList as the array argument. Here we only need to specify the array name numList. When we pass an array object's reference into a method, we need not pass the array length as an additional argument because every array knows its own length. Note that array parameter is used to pass the entire array to the method. To pass an individual array element to a method, you use the indexed variable as an argument in the method call, just like passing an argument of the same type as the element type. For example, here recall that the methods sqrt in the math class takes a double variable as a parameter. So you can pass any double argument as the argument to the method. And so here the array numList has the elements of time doubles. So you can pass any element of the array numList, for example, numList 0, as an argument to the methods sqrt of the math class. There's a little difference in the passing mechanism between array arguments and primitive type arguments. When an argument to a method is an entire array or any reference type argument, the call method receives a copy of the reference, that is, the copy of the memory address stored in that reference. However, when an argument to a method is of a primitive type, the called method receives a copy of the argument's values. Such primitive values are called scalars or scalar quantities. So those are the values stored in a memory location. This parseArray.java program demonstrates the difference between passing an entire array and passing a primitive type array element to a method. The class parseArray of this program has three methods, including the main method. One of the other two methods is the modifyArray method, which is a void method and takes one array parameter. The modifyArray method will modify the array argument. The method main starts with declaring and creating an array of 5 int elements initialized to the values of 1, 2, 3, 4, 5. Then it displays the values of the original array before the array is passed to the method modifyArray. This enhanced for statement just goes through the array elements and displays their value. Next, the method main calls the method modifyArray, passing the array variable as an argument. Method modifyArray receives a copy of array's reference and uses the reference to multiply each of the array's elements by 2. After the call, it displays the values of the array variable using the same enhanced for statements as the one above. To show the difference between passing an array and passing an array element, the method main of the parseArray.java program also calls the method modifyElement with the element array3 as an actual argument. The value of array3 is displayed before and after the modifyElement method called by the main method. Here are the definition of the modified array method and the modify element method. Method modify array takes an array parameters of element type int and multiplies every element of the array parameter by 2. So it modifies the entire array. Method modify element takes an int parameter and also multiplies the parameter by 2. It also displays the value of the parameter inside the method after multiplying. Here are the results of the parseArray program. As you can see, the values of the original array are 1, 2, 3, 4, 5, as in their initialization. After calling the modify array on that array, the elements of the array are changed to 2, 4, 6, 8, 10. And before calling the modify element method, the element array 3, this is array 3, has value 8. When element array 3 is passed to the modify element method, only the copy of its value, which is 8, is passed to the method. So during the execution of the modify element method call, the parameter is changed by doubling. So the value of the element inside the modify element method is 16. After the call terminates, the value of array 3 is still unchanged, which is 8. In general, when a primitive type array element or any primitive type argument is passed to a method, modifying the parameter in the count method does not affect the original value of the argument in the calling method because only the copy of the value is passed to the method. In the last section of this video, I'm going to explain the difference between passing mechanisms, pass by value and pass by reference. Those are the two ways to pass arguments in method calls in many programming languages. When an argument is passed by value, a copy of the argument's value is passed to the count method. The count method then works exclusively with the copy. Changes to the count method's copy will not affect the original variable's value in the caller. In contrast, when an argument is passed by reference, the argument must be a variable. It cannot be a literal value or any other expressions. The corresponding parameter associates with the same memory location as the argument, and the count method can access the argument's value in the caller directly and can modify that data if necessary. All parameter passing scenarios we have seen so far are pass by value. But to see how it differs from pass by reference, let's consider the example of the modify element method in the pass array program. This method takes one int parameter named element, then multiplies element by 2 and finally print out the value of element. So the value of element is changed inside the method. Now consider a call to the modify element method with the argument being a variable and declared in the caller. When this method call starts, the activation record of the modify element method is created, which includes the memory allocation for the parameter element. Then the value of argument n, which is 5, is copied from its memory location in the caller's activation method into the memory location allocated to parameter element. The modify element method will then work exclusively with this copy, which is separate from the memory location for the argument end. At the end of the method call, the parameter element has been modified by the method, so its value has been changed from 5 to 10. But this change is made on the memory location of element only. It doesn't affect the value of variable n in the caller. The value of variable n after this method call is still 5. Now, let's assume that the parameter element in the modify element method were defined with the pass by reference mechanism instead of pass by value. Then, when the argument n is passed by reference in the modify element method call, the parameter element receives the reference of variable n and can access the value of variable n in the caller directly. There's no memory allocated for the parameter element inside the activation record of the modify element method. Instead, the parameter element becomes another name for the same memory allocation associated with the variable n in the caller's activation method. In other words, for this same memory allocation, the caller of this call will refer to it as n, and the modify element methods will refer to this memory location as element. Okay, so the allocation same thing but with two different names. So any change to the parameter element in the modify element will also change the value of the variable n in the caller. So when the element parameter is changed from 5 to 10, so is the variable n in the caller. Note that Java does not allow you to choose a pass-by value or pass-by reference, as in other languages like C or C++. In Java, all arguments, including reference type arguments, are passed by value. So a method call can pass two types of value to a method: copies of primitive values or copy of references to objects if the parameter is of a reference type. But note that objects themselves cannot be passed to methods. And when a method modifies a reference type parameter so that it refers to another object, then only the parameter refers to the new object. The reference stored in the caller's variable that is used as the argument still refers to the original object. Here is an example that demonstrates the effect of pass-by value of a reference type parameter, such as array parameters. In this example, we have a method test that takes one array parameter named p of int elements. Inside the method, it first assigns element p1 to value 6. Then it creates another array of 4 int elements and assigns p to the new array. So parameter p refers to a new array object after the second assignment statement in the test method body. Finally, the method test assigns element p1 to value 7. Now consider a call to the test method passing an array A created in the caller as the argument. Array A was created with the array initializer with element values 1, 2, 3, 4, 5. So in the caller's memory space, it has memory allocation for the array object itself and the memory allocation for variable A. Note that the memory space of a method includes its activation record on the stack and the space on the heap where the memory for objects are allocated. The value stored in the memory location associated with variable A is the memory address or reference of the first element A0 of the array object. In other words, the array variable A refers to this array object in the caller. When the test method call stores, a memory location is allocated to a parameter p in the method test activation record, which is in the memory space of method test. Then the value of argument a is copied from its memory location in the caller to the memory location of a parameter p. But the value being copied is the reference or memory address of the array object created in the caller. So at this point, the parameter p refers to the same array object as the array variable a in the caller. In other words, p0 is the same as a0, p1 is the same as a1, p2 is the same as a2, and so on. So when method test assigns p1 to 6, the value of element a1 in the caller is also changed to 6 because at this point p1 is the same as a1. But after parameter p is assigned to another array object created in the method test, the parameter p no longer refers to the array object um, in the caller. It now refers to the new array object in the memory space of the test method. So when the method test assigns a p1 to 7, it only modifies the element at index 1 of the new array object. The value of the element at index 1 of the array object in the caller is unchanged, and the variable a in the caller still refers to the original array object in the caller. So the value of a1 is still 6. If you print out the element a1 after the uh, test method call, it will show the value 6 instead of 2 or 7. Note that here only the reference of the array created in the caller is passed to the method test, not the entire array object is passed. This makes sense for the performance reasons because passing a large array object would waste time and consume considerable memory for the copies of the element. Alright, that's all for this video. Thank you for watching, and I hope to see you again in the next video, which is part 3 of arrays in Java.